Good evening, my YouTube viewers. In this particular video, what we're going to discuss is decomposition. And decomposition separates time series data into its underlying components of trend, seasonality, and residuals. And this technique provides clarity on the driving forces behind data. And so what we're going to do is we're going to analyze sales data to separate seasonal holiday spikes from overall growth trends. And we're going to do that by writing a program in Python. And so the first thing that we're going to do is we are going to import 4 libraries that we're going to need to use to accomplish this. So the first library we're going to import is NumPy SNP, which is a numeric library. And then we're going to import pandas SPD, which is a data processing library that creates data frames. And we're going to import matplotlib.pyplot_splt, which is a data visualization library. And from statsmodels.tsa.seasonal, we're going to import seasonal decompose. So statsmodels is a library that I've spoken about in previous videos. It's Python statistical library. TSA stands for time series analysis, and seasonal deals with functions to do with seasonality. So we're going to generate some synthetic data for sales covering 2 years of daily sales. And the first thing that we're going to do is we're going to set our seed. And the reason why you set your seed is because every time you run the program, you want to be initialized to the same values. And so that's what happens when you set your seed. So you type up np.random.seed, and then you can put any number you like within the brackets. And then so now we calculate the days. So days equals pd.daterange brackets start equals 2023-01-01, comma, end equals 2024-12-31, frequency equals D. And then trend equals np.linespace brackets 50, 200, len days. That's a linear growth trend. Seasonality equals 20 times np.sine brackets 2 times np.pi times days.day of year divided by 365, and that's the seasonal holiday spikes. Noise equals np.random.normal brackets 0, 5, len days, and sales data equals trend plus seasonality plus noise. So we're going to create a data frame for the sales data. So sales df equals pd.dataframe brackets, curly brackets, date, days, date colon days, sales colon sales data. And so that's first column is your date, and then the second column is your sales. And then sales df dot set index brackets date, in place equals true. So that means your date is your index. So we're going to apply seasonal decomposition. Result equals seasonal decompose bracket sales df square brackets square sales, model equals additive, period equals 365. So you have yearly seasonality. So we're going to plot the decomposed components, observed, trend, seasonal, and residuals. So plt.figure brackets fig size equals 6, 5. Observed data equals plt.subplot brackets 4, 1, 1. plt.plot brackets residual.observed, label equals observed cells, color equals blue, plt.title is observed sales data, plt.ylabel is sales, and you get a legend. So now we put in the trend component, plt.subplot brackets 4, 1, 2, plt.plot brackets result.trend, label equals trend, color equals green. So plt.title is trend component, ylabel is sales, and then you get a legend. And now we plot the seasonal component. So plt.subplot brackets 4, 1, 3, plt.plot result brackets result.seasonal, label equals seasonality, color equals orange. plt.title is seasonal component, ylabel is sales, and you get a legend. And now we're going to plot the residuals. plt.subplot brackets 4, 1, 4, plt.plot brackets result.resid, label equals residuals, color equals red, plt.title brackets residual component, plt.ylabel is sales, plt.xlabel is date, and then you get a legend. So you adjust the layout to show the plot, plt.type layout, and we show the plot. And this is the plot that we have shown. You have the observed data, so you've got your observed sales. And then you've got your trend. Observed sales are from like 0 to 200. Then you've got your trend, which like maybe 50 to 200. Then you've got your seasonal component, your seasonality, and that's -25 or to +25. And then you've got your residual component, which is close to 0. So that concludes this video. The next video is going to be on exponential smoothing, and I hope that you decide to watch it.